Every second, somewhere in the world, a 400-ton metal beast slams into concrete at 180 miles per hour, generating enough heat to melt steel and forces that could crush a car into a pancake. Yet the 6 rubber circles beneath it never explode, never shred, never fail. This isn't luck. It's engineering that defies everything you think you know about tires. Picture this. Your car tire bursts hitting a pothole at 30 miles per hour. Meanwhile, an Airbus A380 pounds the runway, carrying the weight of 40 elephants, moving 6 times faster than highway speed, with tires that somehow shrug off impacts equivalent to a controlled demolition. The rubber should disintegrate instantly. The rim should crack. The entire landing gear should collapse in a spectacular fireball of twisted metal and screaming passengers. But here's what nobody tells you. Airplane tires operate in a realm of physics where normal rules don't apply. They endure temperatures hot enough to bake pizza, pressures that would make your head explode, and forces so violent they'd turn ordinary rubber into confetti. Yet, pilots trust their lives to these mysterious black circles without a second thought. What if I told you everything you believe about tire durability is completely backwards? The very conditions that would annihilate regular tires are exactly what makes airplane tires indestructible. This isn't just rubber meeting road. This is materials science bordering on magic. And the secret will change how you see every landing forever. When Flight 447 touched down at JFK last Tuesday, its tires went from 0 to 170 miles per hour in the blink of an eye. Not speeding up, but catching up to a runway screaming beneath them at highway velocity. In that split second of contact, each tire experienced forces equivalent to being struck by a freight train while simultaneously being roasted in an oven set to 500 degrees Fahrenheit. Let's put this insanity into perspective. Your SUV weighs maybe 5,000 pounds, spread across 4 tires. A Boeing 777 weighs 660,000 pounds, crushing down on just 6 rubber patches, each no bigger than your coffee table. That's 110,000 pounds per tire. Imagine parking 22 cars on top of a single Michelin radial. Now slam that tower of vehicles into asphalt at the speed of a Formula One race car. The physics gets even more brutal. During touchdown, airplane tires don't just absorb weight, they're instantly spinning up from stationary to match the aircraft's ground speed. This creates a rotational acceleration so violent it generates G-forces that would liquefy human organs. The rubber surface heats up faster than a blowtorch, reaching temperatures that could literally cook an egg in seconds. But here's where it gets truly impossible. While your car tire might encounter a 50-degree temperature swing on the hottest summer day, airplane tires routinely survive 300-degree temperature differentials. They're frozen solid at cruising altitude, then instantly superheated upon landing. It's like dunking a block of ice directly into boiling oil and expecting it not to shatter. The pressure differentials are equally insane. At 35,000 feet, the atmospheric pressure is so low your blood would boil. Yet airplane tires maintain their shape and structural integrity, while your car tires would become worthless balloons. Then they plummet through 7 miles of atmosphere, experiencing pressure changes that would crush submarine hulls. Consider this. NASCAR tires, engineered for extreme performance, regularly explode at 200 mph, even without the added complexity of altitude changes and temperature swings. Race car tires are replaced every few hundred miles because they simply can't handle the punishment. Meanwhile, airplane tires endure conditions that make NASCAR look like a leisurely Sunday drive through suburbia. The energy dissipation alone should reduce them to smoking rubber soup. When a 747 lands, each tire must absorb and disperse kinetic energy equivalent to the explosive force of several hand grenades detonating simultaneously. The heat generated is enough to power a small house for an hour. So how is this even remotely possible? The answer isn't just engineering, it's a complete reimagining of what rubber can become when pushed beyond every conceivable limit. What airplane manufacturers discovered will blow your mind. The rubber touching that runway isn't rubber at all, at least not the kind you've ever encountered. What looks like ordinary black tire material is actually a classified compound originally developed for military applications, so sensitive that its complete formula remains locked in aerospace vaults. This isn't synthetic rubber, mixed with carbon black like your Honda Civic. This is synthetic rubber, infused with materials that were literally science fiction just decades ago. Inside every airplane, tire lies a secret architecture that would make NASA engineers weep with envy. Forget everything you know about tire construction. Airplane tires are built like miniature skyscrapers, with up to 40 separate layers of exotic materials precisely engineered to work in harmony under impossible conditions. Each layer serves a specific function. Some absorb heat, others distribute weight, and the innermost cores are designed to contain explosions. The cored materials alone read like a chemistry textbook from the future. While your car tires rely on basic steel belts, airplane tires are reinforced with aramid fibers, the same material used in bulletproof vests and spacesuits. These synthetic threads are 5 times stronger than steel by weight and can stretch like elastic bands while maintaining their structural integrity. But here's the kicker. Some military aircraft use tire cords made from materials so advanced they're classified as weapons technology. Then there's the pressure secret that airlines desperately don't want you thinking about during takeoff. Your car tires operate at maybe 35 psi. Airplane tires are inflated to over 200 psi, creating internal pressures that could literally launch your body like a cannonball if they ever ruptured. This isn't just about supporting weight. It's about creating a pressure vessel so robust it becomes virtually indestructible. But here's what nobody tells you about that pressure. It's not filled with regular air. Every commercial airplane tire is inflated with pure nitrogen, and the reason will terrify you. Regular air contains water vapor that turns to ice at cruising altitude, then explosively expands into steam during landing. Nitrogen remains completely inert, preventing internal explosions that would turn tires into fragmentation bombs at 35,000 feet. The manufacturing process reads like something from a spy thriller. These tires are vulcanized in autoclaves, massive pressure cookers that subject them to conditions more extreme than most spacecraft endure. The rubber is literally cooked under pressures equivalent to being 3 miles underwater, while simultaneously being heated to temperatures that would melt aluminum. This molecular transformation creates cross-linked polymer chains so dense they're practically bulletproof. Cross-sections reveal the true engineering marvel. Multiple rubber compounds layered like geological strata, each formulated for specific thermal and mechanical properties. The outer tread is designed to grip runways slick with jet fuel and monsoon rains. The middle layers distribute catastrophic impact forces across the entire tire structure. The inner liner contains pressures that could power hydraulic systems while remaining completely impermeable to gases that would leak through conventional rubber in minutes. Some tires incorporate heat-dissipating compounds that actually improve performance as temperatures soar. While regular rubber degrades and melts, These exotic compounds become stronger and more flexible when superheated, turning what should be a fatal weakness into a tactical advantage. But this incredible engineering represents just the beginning of the story. The real magic happens in systems you've never heard of. Technologies so advanced, they border on the impossible. What comes next will fundamentally change everything you think you know about safety. What if I told you that airplane tires are designed to fail? Not accidentally, deliberately. Every single tire on a commercial aircraft is engineered with the assumption that it will catastrophically explode, and the entire landing system is built to keep you alive when that happens. Here's the mind-bending reality. Airlines operate on a principle called acceptable failure rates. Boeing and Airbus actually calculate how many tire explosions they expect per million landings, then design systems that make those explosions completely irrelevant. Your safety doesn't depend on perfect tires. It depends on perfect backup systems. Look beneath any commercial airliner and count the wheels. 6. Wrong. What you're seeing is actually multiple independent tire systems clustered together in configurations that seem redundant until you understand the psychology of aerospace paranoia. Each main landing gear assembly contains multiple tire pairs specifically designed so that half of them can simultaneously explode without affecting your ability to land safely. But here's what pilots have access to that passengers never see. Real-time tire pressure monitoring systems that would make Formula One teams jealous. Every single tire is constantly monitored by sensors that detect pressure changes smaller than what you'd notice letting air out of a bicycle tire. These systems don't just alert pilots to problems, they predict failures minutes before they happen, calculating exactly which runway approach angles will compensate for compromised landing gear. The rotation systems reveal even deeper engineering wizardry. Unlike your car, where tire rotation is a maintenance suggestion, airplane tires are continuously rotated through computerized protocols that ensure wear patterns never compromise structural integrity. Airlines maintain databases tracking every single tire's history. How many landings? What temperatures? Which runways? Even the pilot's landing technique. This data determines rotation schedules so precise they're calculated down to individual flights. Emergency procedures go far beyond what most people imagine. Pilots train for scenarios where entire landing gear assemblies fail, practicing techniques for landing aircraft on foam-covered runways with blown tires shooting sparks like 4th of July fireworks. These aren't theoretical exercises, they're monthly drills preparing for situations that happen, more often than airlines advertise. The pressure monitoring extends to predictive failure algorithms that sound like science fiction. Sensors detect microscopic changes in tire flex patterns, identifying internal structural damage hours before visible symptoms appear. When the system predicts imminent failure, ground crews can replace tires during routine turnarounds, often while passengers are still boarding their connecting flight. Here's the part that will blow your mind. Some aircraft can actually land safely with 0 functional tires. Emergency belly landing procedures, while dramatic, are so well rehearsed that survival rates exceed 95%, even in worst-case scenarios. The aircraft structure itself becomes the landing gear, sliding along specially designed runway surfaces that dissipate energy more effectively than tires ever could. What nobody tells you is that tire redundancy is just the surface layer of safety systems, so sophisticated they operate in complete silence, making split-second decisions that keep millions of passengers safely airborne. But the real secret isn't the technology. It's what happens when everything goes perfectly wrong. Deep in the Nevada desert sits a facility that looks like a torture chamber for tires. Welcome to the Michelin Aircraft Tire Testing Center, where engineers spend their days finding creative ways to destroy the world's most indestructible rubber. What happens here would make your mechanic question everything they know about tire durability. Picture this: a 50-foot diameter spinning wheel spinning at 250 mph, designed to slam airplane tires into concrete blocks, while subjecting them to forces that would turn ordinary rubber into confetti. This isn't just testing, it's systematic annihilation. Engineers deliberately create conditions more extreme than any real aircraft would ever encounter, pushing these tires past their breaking point just to map the boundaries of impossible. The temperature torture chamber is equally brutal. Tires are frozen to -80 degrees Fahrenheit, cold enough to shatter steel, then instantly exposed to 600-degree flames while spinning at landing speeds. The goal isn't to see if they survive, it's to document exactly how they fail when pushed beyond any conceivable real-world scenario. But here's where it gets fascinating. When airplane tires finally do reach their breaking point, they don't explode like car tires. They fail gracefully, almost politely. The exotic rubber compounds begin degrading in predictable patterns, creating visible warning signs long before catastrophic failure becomes possible. It's like they're programmed to whisper, "I'm dying," rather than screaming it through explosive destruction. The hydraulic crushing tests reveal the true limits of these engineering marvels. Technicians place tires in hydraulic presses, capable of generating pressures equivalent to parking the Empire State Building on top of them. Most airplane tires withstand forces exceeding 2 million pounds per square inch before showing structural damage. To put that in perspective, the pressure at the bottom of the Mariana Trench is only 16,000 psi. When things do go wrong in real-world conditions, the failures are so rare they become case studies analyzed for decades. Delta Flight 1288 experienced a tire explosion during takeoff in 1996, the first documented case of certain failure conditions. The result? A complete redesign of tire pressure monitoring systems and backup, protocols that made similar incidents virtually impossible. The endurance testing pushes tires through simulated lifespans equivalent to 20 years of commercial service, compressed into weeks of continuous punishment. Machines replicate every conceivable landing condition: crosswinds, wet runways, extreme heat, Arctic cold, even simulated bird strikes that would shatter windshields. The goal is to find failure modes that haven't been discovered yet. What's truly remarkable is how rarely these tests reveal actual limitations. More often, they uncover performance capabilities that engineers didn't realize existed. Some tires perform better under extreme stress than under normal conditions, suggesting that the materials actually strengthen when pushed beyond design parameters. The question isn't whether airplane tires can handle everything thrown at them. It's what happens when physics itself becomes the limiting factor. The airplane tire of 2030 will make today's an 132. Engineering marvels look primitive. Deep in Goodyear's secret development labs, scientists are building tires that think, adapt, and heal themselves. Technology so revolutionary it could eliminate tire failures forever. Smart tire prototypes now embed thousands of microscopic sensors throughout the rubber matrix, creating a nervous system that monitors structural integrity in real time. These sensors don't just detect problems. They predict failures with supernatural accuracy, sending alerts to ground crews weeks before human inspectors could spot microscopic damage. But here's the kicker: they're learning. Machine learning algorithms analyze failure patterns across millions of landings, becoming smarter with every touchdown. The materials revolution goes far beyond smart rubber. Researchers are experimenting with graphene-infused compounds that are literally stronger than diamond while remaining flexible enough to bend like putty. Early prototypes demonstrate impact resistance so extreme they can withstand direct artillery hits without losing structural integrity. This isn't just incremental improvement, it's physics-defying advancement that makes current tire technology look like horse-drawn carriages. Airless. Tire designs represent the holy grail of aviation safety. Bridgestone's prototype honeycomb structures eliminate the possibility of pressure loss entirely, while maintaining all the shock absorption properties of pneumatic tires. Engine landing gear that cannot fail because there's nothing to burst, nothing to deflate, nothing to monitor except wear patterns that could theoretically last decades. Self-healing polymers sound like science fiction until you see them in action. Puncture a prototype tire with a nail, and molecular-level repair mechanisms literally close the wound within seconds. The rubber contains dormant healing agents that activate upon damage, creating bonds stronger than the original material. Some experimental compounds can heal from damage that would total conventional tires. Shape memory alloys embedded in tire structures could revolutionize how aircraft handle different runway conditions. These materials automatically adjust tire characteristics based on temperature, surface conditions, and landing speeds. Soft and grippy for wet runways, hard and durable for high-speed touchdowns, all without pilot intervention or mechanical systems. The most mind-bending innovation involves tires that generate their own power. Piezoelectric materials woven into the tire structure harvest energy from every compression and release cycle, potentially powering aircraft systems through landing forces alone. Early calculations suggest large aircraft could generate enough electricity during landing to power ground operations. But here's what will blow your mind. This technology won't stay in aviation. These same innovations are already migrating to automotive applications, promising cars with tires that never need replacement, never lose pressure, and automatically adapt to road conditions. The future of transportation is being written in airplane tire labs, where the impossible becomes inevitable. Every time you walk past an airplane on the tarmac, you're looking at 6 black circles that represent humanity's conquest over physics itself. What seemed like simple rubber wheels are actually masterpieces of materials science, each one containing more engineering innovation than most people encounter in their entire lives. This is the hidden reality of modern aviation. Your safety depends on thousands of invisible miracles working in perfect harmony. Those tires aren't just supporting an aircraft, they're defying everything that should make powered flight impossible. The same obsessive engineering that transforms rubber into indestructible landing systems also governs every rivet, wire, and component keeping you airborne. But here's what nobody tells you about modern technology. Most extraordinary innovations hide in plain sight, disguised as ordinary objects we take for granted. Your smartphone contains materials that didn't exist 20 years ago. Your car's engine operates on principles that would astound engineers from just one generation back. The water flowing from your kitchen faucet travels through infrastructure more complex than medieval cities. Airplane tires represent something profound about human ingenuity, our refusal to accept limitations. When physics said rubber couldn't survive those conditions, engineers didn't accept defeat. They reimagined what rubber could become. When weight restrictions seemed insurmountable, they invented materials stronger than steel, yet lighter than aluminum. When safety demanded impossible redundancy, They built systems that turn catastrophic failures into minor inconveniences. The next time you board an aircraft, take a moment to appreciate those 6 black circles beneath you. They're not just tires, they're monuments to human determination, each one containing decades of research, millions of test hours, and innovations that push the boundaries of what's possible. They represent our species at its finest, taking the impossible and making it routine. Now, you'll never look at airplane landings the same way. Every touchdown is actually a symphony of materials, science, physics, and engineering precision that borders on magic. Those tires aren't just touching down. They're proving that with enough creativity and determination, humans can make anything work. Speaking of incredible engineering that defies common sense, wait until you discover why airplane windows have that tiny hole that could theoretically doom everyone aboard. Picture this. Right now, somewhere in the world, a 747 is touching down at 180 miles per hour. Its 6 indestructible black circles absorbing forces that could level buildings. The pilot doesn't even think twice about those tires because engineers spent decades making the impossible look routine. You now understand what 99% of passengers never realize, that every safe landing represents a triumph over physics itself. Those weren't just tires you learned about today. You discovered classified rubber compounds stronger than military armor, pressure systems that contain forces equivalent to underwater explosions, and backup systems so sophisticated they turn catastrophic failures into minor inconveniences. You've seen inside testing facilities where engineers deliberately torture tires beyond any conceivable real-world scenario and glimpsed future technologies that will make today's miracles look primitive. But here's what I want you to remember. This level of hidden complexity surrounds you everywhere. The mundane objects you encounter daily contain engineering marvels that would astound previous generations. Your morning coffee cup might incorporate materials science breakthroughs. Your car's windshield could contain innovations more advanced than spacecraft components from just 20 years ago. You're now part of an elite group who understands what really happens when airplanes land. Share this knowledge. Blow someone's mind by explaining why airplane tires are filled with nitrogen instead of air, or how they're designed to fail gracefully rather than explode catastrophically. Make them question everything they thought they knew about the hidden complexity of modern technology. If this journey into airplane tire engineering amazed you, wait until you discover the terrifying reason why airplane windows have those tiny holes that seem like design flaws but actually prevent cabin explosions at 35,000 feet. That mystery will fundamentally change how you see aircraft safety, and it's even more mind-bending than what you just learned about tires. The rabbit hole of aviation engineering goes deeper than you ever imagined.